Assalamualaikum warahmatullahi wabarakatuh. We are from Group 8. We will present our presentation about the material is one-way Anova. Members of Group 8, the first is Rakha Praditya Wibowo, the second is Arina Syarifatul Hidayah, and the third is Ilham Roziqun Nafik. We will start the presentation. One-way Anova. Analysis of variance or also known as ANOVA, we will study single factor analysis of variance, also called one-way ANOVA in this section. One-way ANOVA test. A psychologist is studying the effects of dream deprivation on a person's anxiety level during working hours. Brainwaves, heart rate, and eye movement can be used to determine if a sleeping person is about to enter into a dream period. 3 groups of subjects were randomly chosen from a large group of college students who volunteered to participate in the study. Group 1 subjects had their sleep interrupted 4 times each night, but never during or immediately before a dream. Group 2 subjects had their sleep interrupted 4 times also, but on 2 occasions they were woken at the onset of a dream. Group 3 subjects were wakened 4 times, each time at the onset of a dream. This procedure was repeated for 10 nights, and each day all subjects were given a test to determine their levels of anxiety. This is the data table. Record the total of the test scores for each person over the entire project. Higher totals mean higher anxiety levels. From the table, we see that Group 1 had N1 equals 6 subjects, Group 2 had N2 7 subjects, and Group 3 had N3 equals 5 subjects. For each subject, the anxiety score or X value and the square of the test score is as X squared value are also shown. In addition, special sums are shown. Our application of Anova has 3 basic requirements. In a general problem with K groups, 1. We require that each of our K groups of measurements is obtained from a population with a normal distribution. 2. Each group is randomly selected and is dependent of all other groups. In particular, this means that we will not use the same subjects in more than one group and that the score of one subject will not have an effect on the scores of another subject. 3. We assume that the variables from each group come from distribution with approximately the same standard deviation. Step 1. Determine the null and alternate hypothesis. The purpose of an ANOVA test is to determine the existence or non-existence of a statistically significant difference among the group means. In a general problem with K groups, we call the population mean of the group mu1, the population mean of the second group mu2, and so forth. This is the hypothesis for one-way ANOVA. Notice that the alternate hypothesis claims that at least 2 of the means are not equal. If more than 2 of the means are unequal, the alternate hypothesis is of course satisfied. In our dream problems, we have K equals 3 Mu1 is the population mean of group 1. Mu2 is the population mean of group 2 and mu3 is the population mean of group 3. Therefore, H0 mu1 equals mu2 equals mu3 and H1 at least two of the means mu1, mu2, mu3 are equal. We will test the null hypothesis using an alpha equals to 0,05 level of significance. Notice that only the test is being performed even though we have k equals 3 groups and 3 corresponding means. Using Anova avoids the problem mentioned earlier of using multiple tests. Step 2. Find sum of square total. The concept of sum of square is very important in statistics. We use the sample standard deviation and sample variance. The numerator of the sample variance is a special sum of square that plays a central role in ANOVA. Since the numerator is so important, we keep the special name as S for sum of squares. Sum of squares equal to sigma x minus x per square. The next will be presented by Ilham.
Okay, the next step is define as aspect or sum of square between group variability. Recall that x bar total is the mean of all x values from all group between group variability or SSBet measures the variability of group mean. Because different groups may have different numbers of subjects, we must weight the variability contribution from each group by the group size Ni. We have the equation is like here. SSBet equals the sum of Ni times x bar I minus x bar dot square for all groups, where Ni equals sample size of group I, x bar I is sample mean of group I, and x bar dot is mean for values from all group. Okay, next. Or we can use this equation as bet equals the sum of sigma xi square minus ni over ni, I mean minus sigma x dot square minus grid n, where grid n is n1 plus n2 plus n3 and so on, and sigma xi equals sum of data in group I, and sigma x dot is sum of data from all groups. Next. The next is the step 4 is to find SSW. We know that SS dot equals SS bed plus SSW from the explanation before. So we can find SSW equals SS dot minus SS bed. SSW is the numerator of the variation within groups. Inherent difference unique to each subject and differences due to change grid the variability assigned to SSW. In the in a general problem with K groups, the variability within the each group can be represented by SSI equals sigma xi minus x bar I square. It's equivalent with SSI equals sigma xi square minus sigma xi square over ni. Because SSI represent the variation within the each group, then we get SSY equals SS1 plus SS2, SS2 plus SS3, and so on. And next. Right. The next is step 4, step 5, I mean, find variance estimates find variance estimates or mean square. In Anova, there are two types of degree of freedom. There is TF equals k minus 1, that representing the degrees of freedom between groups. And the second one is TFY equals grid n minus k, that representing the degrees of freedom within groups, where k equals the number of groups and grid n grid n equals the total group, the total number size. Note that df plus dfw equals grid n minus 1. And the variance estimates we are looking for are defined as ms bed or s square bed, the variance between groups, or we can read mean square between, and msw or s square w, the variance within group, we can read mean square within. Okay, the next, the formulas of the formulas for the variance between and within samples for follow the pattern of the basic formula for sample variance. We have the equation sample variance or s square equals sigma x minus x bar square over n minus 1 equals ss equal ss over n min 1. However, instead of using n minus I in the denominator for ms bat and msw variance, we use their respective degrees of freedom. So we get mean square between equals sum of square between over df between equals sum of square between over k minus 1, and mean of square within equals ss within over df within equals ss within over n with n minus k. Okay, the next step will be explained by Rakha.
The next step is subject is find the F ratio and complete the Anova test. So the sample F ratio is where the formula of F equal mean square between over mean square within of the group. The F ratio is the sample test statistic F for Anova test. Next. Next slide. Uh, after on step the conclude about how to construct a one-way ANOVA test, we need the k independent data group, with each group belong to a normal distribution and all group having approximately the same standard deviation. N is the total number of data value across all group. For the procedure, first set the level of significance alpha and the hypothesis HO and H1. Next, Let's compute this sample test statistic F using the following step or appropriate technology. You can one of the way is finding the sum of square with total between and within group. Next, third is find or estimate the p-value using the F distribution and using the test rectile test. Fourth, conclude the test. If p-value is less than equal alpha, then reject the hypothesis, null hypothesis. If p-value more than alpha, then do not reject null hypothesis. And last, interpret your conclusion in the context of the application. To to make the to make it easier, you can use the table as the show. Here, you need the sum of square, the degree of freedom, square, F ratio, and so on. Basically, you put your calculation in the table, so it's more easy for for take the conclusion and the conclusion for the ANOVA test. Next. Here is a sample of the excerpt for ANOVA. Psychology studying pattern recognition skill under for laboratory setting. In each setting, a fourth grade child is given a pattern recognition test with 10 patterns to identify. In setting, first, the child is given praise for each correct answer and no comment about the wrong answer. In second setting, the child is given criticism for each wrong answer and no comment about correct answer. In third setting, the child is given no praise or criticism, but the observer express interest in what the child is doing. And last, observers remain silent in a judgment room, watching the child through a one-way mirror. A random test of fourth grade children was used, and each children participate in the test only. The test follow look from the table. Next. So how to do it? We fill the missing the table that is a sigma of x total as shown and the number of participants from every group. There are 20. The next is what assumption are we making about the data to apply a single factor ANOVA test? It's because each of the group comes from the independent random sample that no child was tested twice. We need to assume only that each group of data came from a normal distribution and all of the group came from distribution with about the same standard deviation. Next. Next, we determine about the null and alternate hypothesis, which is for the null hypothesis mu1 equals mu2 equals mu3 equals mu4, or all the mu are the same. And the alternate is not all the means from mu1, mu2, mu3, or mu3 are equal. Next. To do it, we need to find the sum square of the total. From this case, we found 92,950. And next, we found the sum square between the group with the following calculation, and we found there are 50,617. Next. Next, please. The next one is find the sum of square within the group, and we check the calculation using the formula of sum of square total equals sum of square between the group and sum of square within the group. And the calculation, we found that the sum of square within the group, we found there are 42,323. And we check if the calculation is same, that is 50,617 plus 42,333 is equal 92,950. For this case, we found they are equal. So next. The next one is find the degree of freedom between the group and degree of freedom within the group. For the degree of freedom within the group, we calculate k min 1, where k is the number of group from the data, which is 4, and we found that the degree of freedom from between is 3, and the degree of freedom within we using n minus k, where n is the number of participants from the data, and we found there are 20 for n and for k, and we found degree of freedom of within the group is 16. To check it out, we only need to use n minus 1 is equal degree of freedom between the group plus degree of freedom within the group. For this case, we found they are equal. Next, we'll find the mean square between the group and mean square within the group with the following formula, and we found in this case the mean of square between the group is approximately 60,872, with where the mean square of within the group approximately 2,646. Next. The next is find the F ratio, that is mean square between the group divided by mean square within the group. We found that it's approximately 6,376 for the F on the statistic. Next is estimate the p-value from the table F equals to 600, 376. Here we found the from the table uh, where the degree of freedom is found, and we're using 3, and the second we're using 16. We found the p-value is between 5.29 and 9.01. Next, we are conclude the test using, for this case, using 1% level of significance, and we found the p-value is approximately 0.0048. And since the p-value is less than 0.01, we reject the hypothesis and conclude that there is a significant difference in population mean among the four groups. So we found the laboratory setting does affect the mean scores. Next, to make a summary table, this Anova test using the table that we shown before, and here we input all the calculation to the table, and also the test of the decision that we reject the null hypothesis. Next.
Until now, there is a question from
No question.
okay. If there is no question, this is an exercise from to do the homework for class. This is the question from the homework. All students can do the homework and then collect it into me or Ilham or Rakha, and we will check your answer. I think everything is enough from our presentation. We are sorry if we have some mistakes. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Group 8.